So what is coding? You can think of coding as writing ordered lists of instructions for a computer, like giving instructions to a chef. These ordered lists are called algorithms, just like how you would call this set of instructions a recipe. And like chefs, computers execute code line by line starting from line 1, so it's important that we mind the order in which we write code. We're going to be using Eclipse IDE throughout this video to write our code. For our very first line of code, let's tell the computer to print something out. To do that, we write system.out.println, and then specify what we want it to print in these brackets here. So what we do here is we just write quotation marks, and then we type hello world, for example. And to finish this line, we add a semicolon right here. You can think of these semicolons as like full stops. And if you don't add these, then the program just won't run. So make sure you remember them. And now let's run this program. And here you can see in the console, it prints out hello world. We can also define a sentence inside of a variable. So what we can do here is let's make some new lines like this. And let's write string sentence is equal to hello world. And remember our semicolon. We call this declaring a variable, where we create a new variable, sentence, and assign a value to it. So the value is hello world. When we want to access the data inside a variable, we can call the variable by using its identifier, or name. So the identifier here is sentence. So what we can do is we can replace what we wrote inside of these brackets with sentence instead. And when we run the code, it'll have the same effect as what we had before. What we can also do is change the value of the variable anytime we like by using its identifier, sentence, equals, and then let's just write hello earth, for example. And now when we run the program, it will print out hello earth. And that's because we declare the variable here with hello world, but then what we did is we changed the variable to hello earth. And now when we print the variable, we get hello earth instead. When we define the variable, you might have noticed the string keyword. This statement, hello world, and this statement, hello earth, are what we call strings. Strings are one of the fundamental data types in Java. A string is just any combination of characters put together. Other data types include integers, which are whole numbers, chars or characters, which are just single characters, booleans, which is true or false, or double, which is just a decimal number. Variables in Java can only hold one data type at a time, so something like this won't work. And you can see if we try to run this program, we get an error, and that's because we try to store a string inside of an integer variable. Some data types let you perform operations on them. For example, if you have an int stored in a variable, so here we have 5 stored in the variable number, you can then add, subtract, multiply, or divide the value stored inside with another value. So here, we're adding 5, subtracting 5, multiplying 5, and dividing by 5. You can also use the percent symbol to find the remainder after division. So now, this variable will take the value 10, this variable will take the value 0, this will take the variable 25, this will take the value 1, and this will take the variable 0 because 5 divided by 5, and the remainder is 0. You can also update a variable using operations. So here we have number was equal to 5. Now this line of code tells the program to add 2 and then update number accordingly. So after this, number will become 7. And there's a special notation for incrementing by 1. It's just going to be putting the identifier and then putting plus plus. And after this, number will become 8. If you have a string, you can concatenate them, meaning stick them together by adding them together like this. You can also find a string's length by using the length function, or convert all characters to upper or lowercase with these two functions. You can also find the character at a specific location in the string. You just need to remember that the first character of a string has index 0, and it increments by 1 for each subsequent character. Finally, the substring function takes a snippet of the string within a given range. When we specify 1 and 4, we're saying take this snippet of the string ranging from location 1 to 4, but don't actually put in the character in location 4. So now let's just run the program to verify all of this. So we see here that we have concatenated grape and juice into grape juice. And we know that this word's length is 5, so we've got that. We've got everything uppercased over here, and we've got everything lowercased over here. And of course, the index or the character at the index 0 is going to be G, as it's the first character. And the substring should take the second, third, and fourth letter, which we've got right here. You can also compare different values by using any of these comparison operators. The resulting output is a Boolean value, stating whether the comparison is true or false. So because number 1, 10, is bigger than number 2, this result 1 will store the value true because number 1 is bigger than number 2. And if we print result 1, the program will just print true. For characters, the comparison is based off the ASCII code that is assigned to. So here, because C is not equal to G, this result 2 will print out false. And we can see that in action if we run the code right now. You see, we got true and we got false over here. The main use case for these are if statements. An if statement only executes the inside code if the condition is true. So for example, if number 1 is greater than number 2, then run this print statement. And because 10 is greater than 5, if we run this program, we can see that it's printed this line of code right here. But if we change the condition to be less than, now because 10 isn't less than 5, if we run this, then we don't get anything printed. And that's because this code is just skipped entirely. You can also use an else statement like this. Now what this does is this only runs if the preceding if statement is false. So let's write system.out.println, and let's just write like no, for example. And now if we run the code, we can see that no is printed because this if statement was false. What you can also do is you can say else if. So if this is false, then it checks the second condition over here. So let's say if number 1 is equal to number 2, then print equal. And let's set this equal to 5. Then if we run the code, now because 5 isn't less than 5, it goes to this else if. Because 5 is equal to 5, it will print out equal. If you want to check multiple conditions at the same time, you can use one of these symbols over here. If two conditions are placed like this, with the AND symbol in between, then both conditions must be true for the variable combined to be true. So here, 10 is bigger than 5, so this will be true, but 30 isn't less than 20, so this will be false. And because we have a true and a false, combined will be false. So if we now run this program, it'll print out false. If an OR symbol is used, then only one of these conditions must be true for combined to be true. So because 10 is greater than 5, combined will now be true. And because this is true, it'll run this print statement over here. If you use a not symbol, so like that, then the condition inside of here that we're notting, I guess, is inversed. So because this is true, and we put the not symbol over here, that means that this will become false. What if we wanted to repeat a block of code a set number of times? Instead of pasting the same block of code repeatedly like this, you can use loops. There's two kinds of loops. First is a counted loop or for loop. A for loop repeats code while counting to a certain number. This for loop over here starts at 0, increments by 1 each time the loop is repeated, and when it hits 5, it stops repeating, as this condition becomes false once it hits 5, because 5 isn't less than 5. The number it counts is stored in this variable I, which you can access anywhere within the loop. This for loop simply repeats this print statement 5 times. This for loop prints numbers sequentially from 1 to 5 inclusive, by using the counter variable I in here. Here, I starts at 1 and increments until this condition becomes false. The first instance of that is 6, because 6 isn't smaller than or equal to 5. If we now run this program, we can first see all of these I'm cool messages over here, but we can also see the numbers 1 to 5 printed in order. Here, you can change the number that the loop repeats up to, so here, let's just change this to 10, or we can change the starting number, so like we can start at 3, or we can change the increment. So let's make this increment by 2 each time. So now when we run this program, we can see it starts at 3, then when the loop repeats once, I increments by 2, so it becomes 5, and then becomes 7, becomes 9, but then when it hits 11, 11 is greater than 10, so this condition is false, so it stops repeating. You can even set the increment to go downwards like this, and if we edit the starting variable and the condition to be something like this, then it'll count down like this. The other kind of loop is a conditional loop, or while loop. A conditional loop repeats the code while the condition inside these brackets holds true. This while loop simply mimics a for loop, where a variable I is set, and each time the loop is repeated, the variable I is incremented by 1, and the loop repeats until I is not less than 5. So if we run it, then we just get 5 instances of this print statement. But remember, this condition can be anything, like for example, while a Boolean variable stays false. You need to be careful with conditional loops to make sure that indefinite loops don't happen. For example, if we take this incrementer out, then run this program, then we just get an infinite chain of I'm cools, which we don't want. You can also write a loop inside of a loop. This is called nested loops. In the case of for loops, make sure to set the loop variable as something other than I. The most common alternative, which we've used here, is j. This code visualizes how the variables I and j change as the program progresses. So at first, we can see that both I and j is equal to 0. And in the next iteration, we see that j has incremented by 1, and it keeps incrementing until it becomes 4. Now, after it hits 4, this for loop has completed one cycle. And after it completes one cycle, it starts again at 0, but this time with I being 1 more than before. So it starts again at 1, 0, and j goes from 0 to 4 again, so it goes up to here. Then again it terminates the cycle, and it starts again with I being 2, and so on. Let's take a closer look at the loop variable I. You'll notice that if you try using I anywhere else in the code outside of the loop, it won't work. This is because of a concept called scope. The loop's variable scope is only within the loop, meaning that code outside of the loop can't see or access it, meaning that this print statement over here won't work. We call the scope local. In Java, other variables that are declared inside of any loops or if statements are also local to that specific statement, like this temp variable over here. But variables that are declared outside of any loops or if statements are called global variables, meaning they can be accessed from anywhere. So this character, C, can be printed.